All right, guys, here's day 9. I didn't put this in the other unit so that we could finish limits and get a test in. So we'll do this one today. It's just a review of something I taught you earlier in the year, the intermediate value theorem. So it's because given a continuous, add that in, a continuous function, if f of 1 is 3 and f of 4 is -6, does f of x have at least one 0? Okay, so let's take a look. So this means 1, 3 is a point. And this one means that 4, -6 is a point. If we were to graph this, let me move it up a little bit. Right, if we were to graph it, it looks like this. Now it says that it's a continuous function. So if it's a continuous function, it is to get from this point to this point, it is going to have to cross over the x-axis. So therefore it does have at least one 0. Now why at least one 0? I don't know, it could come back down again, right? It could be something like that. So the answer is yes, but the real reason the answer is yes is because the y values are above and below the x-axis. Now, we're not going to always graph something to see. What we really want to look at is there a positive and a negative y value? If there is, then it will cross over the x-axis. And this is the intermediate value theorem. All right, so here it is in words as well, and I think it's important for you guys to be able to read the real definitions. Okay, so let's just look at it. Let me grab a little highlighter. Okay, so it says intermediate value theorem, let a and b be real numbers such that a is less than b. So I drew a little number line there so you can see a is less than b. And it says if f is a polynomial function, remember polynomial function is a continuous smooth curve, such that f of a does not equal f of b. So that means the y value for a does not equal the y value for b. If those y values were equal, then I would have a horizontal line, and therefore it wouldn't cross over. And then continuing, it says then in the interval from a to b, f takes on every value in between f of a and f of b. So it would be a continuous function. The intermediate value theorem helps you locate the real zeros of a polynomial function in the following way. If you can find a value x equals a, at which a polynomial function is positive, and another value x equals b, at which it is negative, you can conclude that the function has at least one 0 between the two values. Yeah, and I don't know if that got together there somehow. Okay, so let's just try a couple problems, and we should remember this in the past. We just didn't talk about it with the continuous function. Determine without a calculator whether or not the equation has a solution, a 0, in the interval 1 to 2. Okay, so just like we did before, I'm going to plug in the number 1. Oh, shoot. I'm going to plug in the number 1. And then I'm going to plug in the number 2. I said like we did before. I meant like we did earlier in the year. Okay, here we wind up with -1, and here we wind up with 5. So the answer would be yes. One negative y value and one positive y value. Okay, so you're just showing it. You just show your work by showing me you get one positive, one negative. All right, next one I want to show you is with a sine function. We could do the same thing. It says show that y equals sine x has at least one solution in this interval. Now we know the basic sine wave, right? God does cross over the x-axis, but they want us to look in this interval. So let's convert to degrees. So we multiply by 180 over pi. Remember, our pi's are gone. Without a calculator, 2 goes in once, goes in 90 times, right? And then 5 times 9 is 45, tack on a 0, so we get 450. So 450 is too big, right? So we'll have to subtract 360. Any angle measures that are bigger than 360, remember, we'll subtract, and we get 90. So this is going to be the sine of 90. Remember the sine of 90? You can think about the wave in your head. So the sine of 90 is 1. What am I concerned with there? That's a positive y value. Okay, let's do the next one. Convert to degrees. So 7 times 9 is 63, tack on a 0. Remember, those pi's are gone. So 630, that's still way too big. So let's subtract off 360, and we're down to 270. Let's find the sine of 270. Sine of 270 is -1. Okay, so show that it has at least 1. So we did show. And we'll just say 1 positive y value and 1 negative. Okay, therefore it has to cross over the x-axis. Okay, so I'm going to let you guys try number 3. Go ahead and do that one. Okay, everybody get -2 and 1? Alrighty, and one more question. It says verify the intermediate value theorem applies to the indicated interval. So we're going to verify again that I get 1 positive y, 1 negative y. And then we're going to find the value of c that's guaranteed by the theorem. That means that I'm absolutely going to be able to find that x value for 3, which lies in between here. Okay, so first let's plug in 0. And we wind up with -7. Then I'll plug in 4. And we're left with 21. Okay, so there we go. We verified it, right? 1 positive, 1 negative. And now they want us to find the value, find this value of c, which is really x, right? If f of c equals 3, so basically they're telling me that y is 3, right? This is c comma 3. So I'll plug in 3 for y. So basically I'm just setting this equal to 3. You could have put the 3 in right here, but we usually like to make it equal on the right-hand side. Subtract 3, subtract 3. I now have x squared plus 3x minus 10 equals 0. We'll factor. X plus 5, x minus 2. We get x is 2. And we get x is -5. Okay, now, the interval, though, that I'm looking at is 0 to 4. So I'm looking at 0 to 4 for my x's. So therefore, this guy is not going to be one of my possible values for c. So it's x equals 2. That would be your c value. Okay? All right, guys, that's it. Just a little review on intermediate value theorem. All right, miss you guys lots. Bye.